Hey everyone, so we had a ton of questions on a previous video where we talked about what our preferred resin was with respect to printing fully assembled trees on a large format 3D printer. Specifically, you guys were asking how exactly I'm building these pre-assembled trees. So I'm going to do a little tutorial with you guys here now, and I'll show you exactly how I do it. And we'll also talk a lot about some of the considerations that I'm making, what kind of designs work really well for this and which ones don't, lots of different aspects. So I'm going to be running you through this on my favorite software, Shapr3D, which is available for iPads, PC, and Mac, and actually brand new. It's all kind of conjoined now with a cloud thing, so it's all really nice and unified. This video is not sponsored by Shapr3D, by the way. I just really like them. I've also tried doing this exact same process with Fusion 360, and it does work with that as well. There are most likely other softwares out there that will do this exact same job, maybe even better. However, this is what I know works, so this is what we're going to be running with. So the first thing we really want to talk about is what kind of designs work for this and which ones don't. This one here, this is a fully printed tree in castable resin. This is ready to go, basically. I did have one break off, but no biggie. I can always just kind of print another one and just attach it. There's lots of things to consider with this, and let's go through a few of those designs now, which ones do and which ones don't. All right, so we're here on the iPad. This is my 12.9-inch M1 iPad. The point of my mentioning that, though, is that because if this device, which is frankly not really, a heavy computing device, can handle this type of workload, then a PC should be no problem. First thing we'll do is look at this design, which is one that I've actually gone so far as to build a tree, print, and cast already. And I can safely say that this design, or this type of design, is not ideal for this method. Now, I realize fully that this is a design that not anyone, likely, is going to really be printing and casting. But if we equate this to something more mainstream, something like an eternity band, for example, this is something you might want to avoid, a certain design that you might want to avoid. The specific reason why this one doesn't work, if we look here at the sprue, this is what would be attached to the main tree. We had these prongs facing inwards towards that center column, and I had a lot of breakage. Naturally, because we're building a tree, or rather printing the full tree assembled, there was really no opportunity for me to actually go and fix them. So I had a number of prongs break off. The other reason is that they all need support towards the tree, buried inside the designs. And again, it just makes it very difficult to actually get at. So this type of design does not work overly well for a fully assembled, printed in place tree. This design is along the same premise as this one. This is a prong stone setting practice. This one is a bezel stone setting practice. This one worked pretty well. Again, I have printed this and cast, and it's worked out perfectly. And I guess the main reason why it worked better is because this one has prongs that were breaking off, and this one doesn't. It is much more robust. It doesn't require nearly as much support. I believe I only had to put like 1, 2, 3 or something on the insides, and then I was able to break them off. So it was very, very simple to support and build, and it just worked really, really well. Now this design is much more up everyone else's alley. You might have stone settings here along the side of the ring or something, but by and large this is more of a typical something you might see at a jewelry store. This type of design works excellent for this type of process because it just simply follows some of the rules. For starters, we have a nice transition from the sprue into the actual ring shank. So it works really nice for self-supporting itself. The peg head stone setting design is does require some support, but because it's on the outside of the tree, it works much, much easier for removing those supports. Ultimately, this is the type of thing that we want to be building, and as you can see, I have done this with the bezel set already. So let's show you how to make this tree using the sample ring. Now I've actually gone ahead and cut off that sprue. We're going to re-sprue and show you how in Shapr you can take an STL file and combine it with a direct 3D file. The difference is with this, I can change the diameter of a direct 3D, but when I import an STL, it is exactly as it was imported. I can't actually edit anything, but you can combine them. So for starters, let's get rid of that and let's make this centered. So I'm going to make this circle, let's say 4 millimeters, as I mentioned before, typical sprue size, and we'll make that, I don't know, 15 millimeters. We can always go back and change it. Now let's bring this up, and I kind of cut that off. We're just going to use it as kind of a guide here. Now I think that was a little bit smaller the last time, so let's just go ahead and match that. Let's go with 3 mil, approximately. I think we might be a little bit off center with this model here. Going a little closer, there we go. Much nicer. Nice and dead center, and we'll make sure that this is actually intersecting. We don't want to have a little microscopic gap in there because it will read that and it could become a problem. So I'm just going to fillet that edge so it's nice and it's got that nice little transition. And then effectively what I could do is just select them both, go union, done, and now they are together. This is now, this cylinder that we were able to mess with is now considered an STL and it cannot be edited. But I can always go undo and I can just change it again. So if I don't want it to be that long, for example, I can go over here, we'll just hide that sketch, bring this into, I don't know, let's say 8 mil. Approximately. Again, this is entirely variable and it will really depend on your design. What do you require from this process to make your design better? All right, so we have our STL that we'll work on. Now let's go back to that center origin. I'm going to make another circle, 9.5 millimeters exactly. Looks like we were pretty close already. And we're going to, oh, we don't want that one. And we're going to extrude this up. Let's say 80 mil for now. It doesn't matter too much. Now at this point, you may want to take a step back and actually go grab some of your casting equipment. For example, if you're like us and you're casting with a 4-inch diameter by 6-inch tall flask, you may want to actually create a virtual version of your flask. So what I've done here is I've made a 100 millimeter circle, which is the diameter of my flask. And I've just made a copy of that, dragged it up, and I've made a 150 millimeter tall, defined the shape of my flask. So I know that I cannot bring my ring all the way up to the very tippy top. So we want to use this as a general guide for making sure that what we print is actually castable. A typical angle that you might want to put your design at is about 45 degrees. However, again, being in CAD, you can make this literally whatever you want. If it's easier to print this at, say, 50 degrees, actually I think this is 55 degrees, then do so, because then you may not ever have to use any supports. Just going to turn on section view, and I'll show you exactly what this might look like as you're printing in resin. So as this is printing upside down, you can see that it just kind of is self-supporting. You've got this little section that's going up, so you wouldn't need to put any supports here and here. As we drag down, it just kind of builds itself up, 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 up. You may want to put a little support there. You may want to put a little support here, but nothing too major. That's very, very doable. And then it looks like the peg just kind of builds itself. So I think we're going to run with that as our default right now. But again, this is entirely variable and it depends on your design. We'll go 90 because then we can fit 4. But this little gap is a little bit small. I bet you it could handle it, but just to be safe, because we are talking about resins here, which do have a thermal expansion factor, maybe we just drop that down and we get a little bit more space. And we can select this guy, copy, go around 180 degrees, and then they're at the same level. Everything's the same. I'm gonna go grab that one, copy, drag around 180 degrees, and everything's good. Now, don't worry, you don't actually have to select all of this individually as we move forward. Basically, you just want to set the bottom 4, then we can go copy and drag up. Well, again, we'll have to figure out exactly how many millimeters up, but you know what? 10 looks pretty good. It's pretty close to those pegs, but it's not too bad. Then we'll drag up again. We'll go up to 20 mil. There. So we're about as high as we can go, and we can then trim this center column to be whatever height is necessary. We'll make sure that, of course, that it's actually intersecting. You can see there it wasn't quite attached. If we go a little bit too low, go like this, and we can fillet the end and make a nice transition. Just make it nice and clean, and we only need as much material as is actually required. So this is a grand total of 40 rings, which is not a bad run. However, I guarantee at this flask size we could almost certainly fit more if we were to go back and adjust that ring angle, because I feel like 55 degrees was a little bit tall. But it really depends on what your values are. Do you want to fit more in the flask, or do you want to just deal with as few supports as possible? I believe that as few supports as possible has a very, very big benefit. The more you stick this out away from the tree, the more these little pegs are going to require some support, maybe here in the middle, maybe you want to put some here, but largely try to stay away from supports on the inside because you just simply can't actually get to them. But you know what, for the sake of just playing around, because this is a digital playground essentially, let's just see how many can we actually fit. The beautiful thing about doing it this way is if you do it right the first time, it's 110% repeatable. So in other words, you can have your printer, pre-sliced, everything is done and ready to go. You just literally hit print, and while you're sleeping, while you're working on other projects, you could be printing a fully printable, castable tree. And I'm pretty sure you could pack this even more if you wanted to. Whether or not you want to get so far into doing this with stone in place or something along those lines is entirely up to you and at your own risk. I personally don't have any experience with stone in place, so take that with a grain of salt. But here is our casting tree. You can see here the iPad is still running fairly smooth using Shapr3D. It is handling it exceptionally well. Now all I really have to do is go here, export as an STL file, and we'll go sample ring tree. And then it's going to automatically essentially unify everything into an STL for us. Save it as this name, and we can save it to whatever we want. And then bring this into our slicing software. In my case, because I prefer Prusa Slicer, I'm going to save to files. And because Shapr is actually using cloud, I can sync this design, and it will automatically go to my computer. So that's one way we can do it as well. Now let's switch over to Prusa Slicer, and I can show you exactly how I will support this for printing. All right, so we have our sample ring tree, which we've loaded into Prusa Slicer. Prusa Slicer is just my preferred slicer. Obviously, I run a Prusa SL1S as my main thing, and it's pretty critical that you're able to fit your tree on your bed, obviously. I'm pretty sure I won't be able to fit 2 on here, but if you have something like, even a Mars, frankly, has a larger build plate than an SL1S. If you have a Saturn, or if you're getting success with a Jupiter, or pretty much any printer these days has a larger build plate than a Prusa SL1S. Not to say that the SL1S is bad. It's going to be able to print this way faster than any one of those other machines. Let's get on to dirty work of getting this printable. So there's a few things that we can do. We could either make this sit flat, or we can support it, and that'll entirely depend on how tall your print is. At some point, you're obviously going to reach the maximum of your printer, and in this case, it's really, really close to the top. So we're going to go to supports, We're going to go object elevation, normally set to 5 millimeters. I believe this is true on Prusa Slicer as well as Chidubox. We're going to do 0. Pad around object. And this is going to make sure that it actually has something around the bottom, attaching it to the base. So now I'm going to go down to the support tab here in Prusa Slicer, and I'm just going to go auto generate. And I don't necessarily advocate for choosing auto generate ever, frankly. I feel like auto generate is just a really good way of finding the islands. It's finding the lowest spots, and it's addressing those for you so that you don't have to. You could go hunting on every single one of these rings and build up and have an amazing support structure all manually, and we're going to go back and look at everything manually in a second as soon as this generates. But I find just running with auto to begin with is a great way of saving some time. So yeah, that is a little bit too much. This is where auto generate definitely struggles. We don't need this. And to prove it, I'm going to hit 1 so I can see the exact top of my object. And we're going to go over here to clipping of view. And we're just going to drag this all the way down so we can do a preview of how this is going to print. Now, I do apologize again. This is really chugging my computer down. But we can see here exactly how it's going to work. So let's go manual edit. We'll clear out some of this stuff, and that'll make it run a little bit easier. So these are the support points on the bottom, and this is how it's going to print layer by layer. You can see here that it kind of just grows naturally into the ring shank. You recall that when we were playing around with the 4, when we had 4 on this tree, we had it at a much higher angle. So that at that point, you may not need any of these supports. In this case, I believe we probably do. We definitely don't need these ones though. They're garbage. They can all go. And then what I'm going to do is, because this is just visible, I'm going to go Control A. I'm going to go over to head diameter, and I'm going to drop that down to 0.3. Because I feel that this is more than adequate. It's already supported by the center column, and we're going to just space these out a little bit. I don't think we need more than 4 tops for this entire section. And that should pretty much always be the goal, if you ask me. Support material is always waste. You're just throwing that straight in the garbage. And of course, it has to be made of the expensive castable material, so minimizing your support usage should always be priority number 1. Not at the expense of failure, because what costs more than support material is absolute failure in your printing it again, throwing everything out, more than the supports would ever weigh. You do have to have a little bit of knowledge and experience with this, but overall, that should be your goal. Now, what I'm going to check here is the last little bit before I move on. So I'm pretty confident that that ring is just going to grow as per usual, but there's a thin area right here as it starts to transition. And that area does need a little bit of support, or it's going to start to sag. So let's put in, it's pretty much already covered it for us. I think these 2 end ones are a little bit extra, and that's pretty much it. Now let's extend up. You know what? It looks like those pegs, they grow at almost a fully 90-degree angle away from the build plate, but they're still going up. There is this island though on the pegs, so I believe this is actually pretty well supported naturally. However, I'm going to go in and just drop these ones down, put this one here, maybe we'll leave that one at 0.3, that one there, 0.3. Just having smaller heads I find really does help with the support removal process. You don't need to have heavy supports if you have your resin dialed in. By the way, I'm using Apply Labs Castable Cyan. as I talked about in that video. It's one of our favorites.
And that's more
it's
or
what I
less
print
what I
pretty
want
much
this to
all
look
of my
like.
casting stuff
Now,
on
I'm
right
just gonna
now.
skip
Ahead, and I will get all of this supported, and we'll show you exactly what this is going to look like. I know this is just one style of printing tree. As you can see here, this is the bezel tree that I have printed and cast already. Phenomenally good results. We've also done this comparatively very weird tree. This one's actually our pave stone setting practice. All of these, by the way, are available at Pepe Tools right now. We are we're manufacturing it for them, and we're selling it to them at wholesale. So they are available to everyone with stones and everything at the moment. The link to that will be down below. This design actually prints better than the rest. You'd think, being so chunky, that it wouldn't. But I did make quite a few very educated guesses when I put this together of how well it would cast. And it works really, really well. Putting the supports, I basically just put them here along the edges, and then everything else after that is self-supporting. I put all the prongs upwards so that they build at an angle. There's no need to have supports on any of this stuff here, and it just works really, really well. And then this is that tree that I showed you at the beginning of the video that I've printed. This will be the second one that I've printed, and then I've cast one already, and the results were phenomenal. If you like this content and you've benefited from it a lot, we would really appreciate anything that you could give us in terms of supporting this channel, whether it's a super thanks or joining our membership program, where you actually have access to me on a more one-on-one basis if you ever have any questions about building trees like this, which casting resins are the best, tips and tricks that I can give you, casting help here and there. There's been a number of people in our community that have benefited quite a lot from this, and I really hope that I can reach more of you out there using educational content like this. So that's all for this video. Thank you very much for watching. I will see you guys in the next one.